In this lesson video, I'm going to attempt to explain, amongst other things, the mass unit mega electron volt per c squared. It's important because particle physicists want to be able to use convenient units for things like mass, energy, and charge. Let's think about charge to start off with. Its SI unit is the coulomb, which is pretty big, to be honest. Since they are working with individual protons and electrons, to get 1 coulomb they would need 6.25 times 10 to the 18 electrons. So, working with individual electrons and protons, it makes sense to use E, that's 1.6 times 10 to the minus 19 coulombs, as the normal unit for charge. The joule is also big, so instead they use a unit called an electron volt. Let's take an electron. It's stationary. Now, put it in an electric field by placing a plate at 1 volt over here. The electron has electrical potential energy now, but no kinetic energy. The electron will move towards the plate so that when it reaches the plate, it will have 0 electrical potential energy and it will have gained kinetic energy. Work was done converting electrical potential energy to kinetic energy, so W equals EP. The defining equation for potential is V equals W over Q, so that is W equals VQ. So, in this case, the work done in accelerating an electron with charge E across a potential difference of V is equal to EV. This, EV, is called an electron volt, and it is a very useful unit for energy. 1 electron volt is the amount of energy gained by an electron that is accelerated through 1 volt potential difference. To convert to joules, well, we simply put the charge of the electron into the equation. So, 1 EV is when V equals 1 volt and E equals 1.6 times 10 to the minus 19 coulombs. So 1 EV equals 1.6 times 10 to the minus 19 multiplied by 1, which obviously is 1.6 times 10 to the minus 19 joules. Or the other way round, 1 joule equals 6.25 times 10 to the 18 electron volts. Remember, 1 electron volt is smaller than a joule, so if you get the maths the wrong way round, it should be obvious to you. Now back to mass, and here we're going to turn to that famous equation E equals mc squared. Which, if we rearrange it, that means m equals E over c squared. Mass is energy over the speed of light squared. And in this, mass is in kilograms, E is in joules, and c squared is in meters squared per second squared. Let's change to electron volts. So, from W equals Fs and F equals Ma, we get W equals Mas. In terms of units, that's joules equals kilograms meters per second squared times meters, or kilograms meters squared per second squared. So kilogram equals joules per meter squared per second squared, with meter squared per second squared being units for velocity squared, of course. And now let's change the joule to the electron volt. So 1 kg equals 1 joule per meter squared per second squared. That's equal to 1 over 1.6 times 10 to the minus 19 electron volts, meter squared per second squared. And that's equal to 6.25 times 10 to the 18 electron volts over meter squared per second squared. And now we're going to bring in the speed of light in a vacuum. We can say that c equals 3 times 10 to the 8 meters per second. Rearranging that, we can say that 1 meter per second equals c divided by 3 times 10 to the 8. And so we get 1 kilogram equals 6.25 times 10 to the 18 electron volts per c over 3 times 10 to the 8 squared. And that's equal to 5.625 times 10 to the 35 electron volts per c squared. Okay, changing to mega electron volts, we're going to end up with 1 kilogram is 5.625 times 10 to the 29 mega electron volts per c squared. And lastly, inverting that, 1 mega electron volt per c squared equals 1.8 times 10 to the minus 30 kilograms. So, remembering that 1U is 1.661 times 10 to the minus 27 kilograms, we can now convert between 3 units for mass. Kilogram, U, and mega electron volt per c squared. We have 3 units for mass and we've got joules and electron volts for energy. We've now got plenty of tools at our disposal to answer some questions and some problems relating to subatomic particles such as quarks and leptons.